Alternatively, we can use a second technique for partial fraction expansion for inverse of Z transform. Again, we use the same example given in the equation, given in the question, but for this one, we need to consider additional of Z function at the numerator. By adding the Z function at the numerator, we also need to add the same Z function at the denominator. So if we cancel out this Z function at the numerator and denominator, we will get the same original equation. Okay, for this one, again, we need to take the Z at the numerator to the left side, so we have xz divided by Z. In this case, it looks like we have 3 poles at the denominator, so meaning that we have 3 parts of partial fraction expansion of based on 3 constants that we need to determine. Again, you need to use your basic knowledge in partial fraction expansion to determine A, B and C. In this case, A is equal to 8, B equal to 8 and C equal to negative 16. And then we substitute all of these value of A, B and C into this equation. We have this one. The next one, we take the Z on the left side at the denominator, we take to the right side, meaning that we multiply with all the A, B and C constant. So by referring to the inverse transform table, this one is actually equal to this signal 8 impulse multiplied with impulse response. Okay, multiply with UN is the unit step function, is standard format, plus 8 multiply with 1 over 2 with the power of n, minus constant 16 multiply with 1 over 4 with the power of n un. In this second technique, time shifting property is not applied in this solution. Okay, based on the 2 solutions shared for this example, which resulted in 2 different equations. The first one involves time shifting property and the second one is not involving time shifting property. So the results are actually similar. So you need to find out how this is possible for the solution from technique 1 and technique 2 are similar. So you need to compare between equation from solution 1 or technique 1 with the solution from technique 2, and you need to find out how these solutions are actually similar.